All right, let's get right into it. Every single programmer, I don't care if you're a rookie or a seasoned pro, you face this choice all the time. How do you get your code to do something over and over again? And the two main tools we've got for that are iteration and recursion.
On the surface, it seems pretty simple, right? Are you going to use a loop, or are you going to have a function call itself? But trust me, this is way more than just a style choice. It's a fundamental decision about how your code is built.
And the stakes? They're actually super high. If you pick the wrong tool for the job, you could end up with the dreaded Stack Overflow error, which basically means your program ran out of memory and just dies. Or you could write code that's so incredibly slow, it's practically useless. So yeah, we need to get this right.
And that brings us to what I call the programmer's dilemma. It's never about which one is just better overall. It's always about which one is the right tool for the specific problem you're trying to solve right now.
At the end of the day, both of these tools are trying to do the same thing. Just repeat some process until a certain condition is met. They just take completely different roads to get there.
So let's lay out the official definitions. Iteration is the one you probably learned first. It's your good old for loop or while loop that just runs a block of code again and again. Recursion, well, that's a bit more of a mind bender. It's when a function solves a problem by calling itself, each time with a slightly simpler version of the problem until it hits a stopping point.
You know, to make this really click, let's use an analogy. Think about counting a flight of stairs. Iteration is like you're at the bottom, and you walk up counting each step as you go. 1, 2, 3. You're keeping track of the count yourself. Recursion is totally different. It's like you're standing at the top, and you have no idea how many stairs there are. So you shout down to the person on the step below you, "Hey, how many stairs are below you?" And they shout down to the person below them, and so on, all the way to the bottom. The person on the last step knows there are 0 stairs below them. That's the base case. Then the answer comes back up the chain. 0, then 1, then 2, all the way back up to you. See the difference?
Okay, this table really gets down to the nitty-gritty trade-offs. Let's talk about space first. Iteration is usually O of 1, which is a fancy way of saying it uses a constant tiny amount of memory, no matter how many times it loops. Recursion, though, uses something called the call stack. Think of it like a stack of plates. Every time the function calls itself, it adds another plate to the stack. The more calls, the higher the stack, and the more memory you use. And that also affects speed. Iteration is generally faster because it doesn't have all that overhead of setting up function calls, of adding and removing all those plates. So right away, you can see a performance trade-off.
All right, that's enough theory. Let's see how these two actually perform in the real world. It's time for a code showdown with a few classic programming challenges.
First up, we've got the factorial function. You know, a classic math problem. It's a really simple, clean way to see both of these approaches in action. And the verdict is, for factorial, iteration is the undisputed champ. Now, they both take about the same amount of time to run. That's what the O of n means. But the real difference is memory. Iteration uses that constant, tiny O of 1 space, while the recursive solution's memory footprint gets bigger and bigger with the input number. For a simple, linear problem like this, iteration is just way more efficient. It's leaner and meaner. Okay, let's move on to our next challenge, walking through a data tree. Now, this is a problem where the structure of the data itself is practically screaming the solution at you.
And for this one, the winner is recursion, hands down. And this shows off the true beauty of recursion. The code itself almost perfectly mirrors the structure of the tree. A node has children, and each of those children is the root of its own little subtree. The recursive code is clean, it's elegant, and it's so much easier to understand than the iterative version, which, trust me, is a mess of managing stacks. It's just clunky.
And for our final challenge, the Fibonacci sequence. Now, this one's a classic, but it's also a huge flashing warning sign for every programmer. It's a powerful cautionary tale. Whoa, just look at this performance chart. The iterative solution is nice and linear, O of n. Totally fine. But the naive recursive solution, its complexity is O of 2 to the n. That's exponential. That's not just slow, it's a performance catastrophe. It means the program has to do a mountain of redundant work, recalculating the same values over and over again until it just grinds to a halt.
And this quote just hits the nail on the head. It's not that recursion is bad. It's that this specific, naive way of using it is horrible. Without some way to remember the results it's already calculated, a trick called memoization, it's like trying to do complex math on a calculator with no memory button. It's a textbook example of how an elegant idea can lead to an absolute disaster if you aren't careful. Okay, so after that Fibonacci train wreck, you're probably asking, so how do I make the right choice and avoid that? Well, let's build a simple, clear framework you can use every single time.
So here's your checklist. You should probably reach for recursion when the problem itself is recursive. Think trees, think graphs, think algorithms like merge sort that break a problem down into smaller versions of itself. It's also a great choice when code clarity is your #1 goal, and you're confident the recursion won't go so deep that it blows up your memory.
On the flip side, you want to choose iteration when you're just dealing with simple sequences, like running through an array. It is absolutely your go-to when performance is critical, when you need that guaranteed O1 space, and especially when there's any chance of a super deep recursion that could crash your program.
You know, understanding these rules isn't just about writing code that works. It's about developing a much deeper understanding of problem solving. It's about truly mastering your toolkit. This is what a lot of people call algorithmic maturity. It's that ability to look at a problem and not just find an answer, but to consciously and deliberately choose the best answer by weighing all the trade-offs: speed, memory, and even how easy the code is to read. This is what really separates the great programmers from the good ones.
And hey, here's a pro tip for your next technical interview. Never just give one answer. Explain why you chose it. Say something like, for clarity, I'm going with a recursive solution here, but it's important to know that an iterative approach would be more memory efficient. That shows a way deeper level of understanding.
So how do you build this skill? You gotta practice. And a perfect problem for this is reversing a linked list. Your mission, should you choose to accept it, is to solve it both ways, once with iteration and once with recursion.
And if you want to find this exact problem, just head over to LeetCode. It's number 206. Seriously, doing it both ways will make all of these concepts stick. Go give it a shot. So now you've got the framework, you have the tools. The next time you're sitting down, staring at a problem, you can confidently answer that question for yourself. What's it going to be? Loops or recursion?